All right, folks, in this video, I'm going to talk about percent yield and how we can use stoichiometry to help us calculate percent yield. So before we get into what percent yield is, let's start talking about how stoichiometry can help us. So when you do a stoichiometry problem, you are solving for the theoretical yield in a chemical reaction. That is, how much product could you theoretically make in an experiment if there are no errors? So if everything went right and there were no errors, how much could you theoretically make of a specific product? However, no experiment is perfect and you never get the amount you calculate. The amount you actually get is called the actual yield. You might also see experimental yield. Okay? In order to compare the two amounts and determine how accurate the experiment is, we calculate the percent yield. Now, a higher yield means that there are little errors in the lab and you've got a good amount of the product you were expecting. Okay, now there's an equation that is used to calculate percent yield. Okay, percent yield equals the actual yield divided by the theoretical yield, and then you're going to multiply by 100 to turn it into a percent. Okay, so the actual yield is what you get in an experiment. So you go into the lab, you do the experiment, you get a certain amount. The theoretical yield is what you should have gotten, okay, if everything went right. And then we can use the percent yield to determine what percentage we actually got. So you're going to complete the following percent yield problems by using stoichiometry to calculate the theoretical yield of an experiment in part A. Then you're going to use this answer as your theoretical yield in part B, where you're also going to be given the actual yield and you're going to calculate the percent yield. The first one has been done for you as an example. Okay, so let's take a look at that. Okay, so in number one, it says potassium chlorate, KClO3, will decompose into potassium chloride and oxygen gas. Okay, hopefully remember decomposition means you take one starting material, one reactant, and you break it into two or more products. So here's the balanced chemical equation for potassium chlorate breaking down into potassium chloride and oxygen gas. Now, in part A, it says if 30 grams of potassium chlorate decompose, how many grams of potassium chloride will be produced? Okay, so let me talk through this problem. Okay, this is stoichiometry using your mole map to go from grams on the left, so mass mol, getting to grams on the right, mass mol B. Okay, so the same stoichiometry problems that you've done last week. Okay, now we always start with our given. Okay, we know we have 30 grams of potassium chlorate, so that is where we have the 30 grams to start. The first step is to convert to moles. So in order to do that, we do 1 mole on top divided by the molar mass. Now we're going to do the molar mass of potassium chlorate, which is 122.55. That was already calculated for us. Okay, so this first step is converting grams to moles. Okay, so we have potassium chlorate, and now we have to figure out what are we looking for. Well, it says how many grams of potassium chloride. That is our unknown. Well, here is potassium chloride on the right. Okay, so our next step is to do a mole ratio. Well, our starting point has a 2 in front, and our ending point has a 2. So we have a 2 mole divided by 2 moles. Okay, whatever you are looking for goes on top. We're looking for potassium chloride, so we put the 2 moles on top and then 2 moles on the bottom. Now it says how many grams, so we need to convert to grams. So we're going to use the molar mass of potassium chloride. In our final step, we put that on top, 74.55 K plus Cl. Put that all over 1 mole. Now for the math, we'll do it like we've always done. Any number on top, you multiply. Any number on the bottom, you divide. So we would do 30 divided by 122.55 times 2 divided by 2 times 74.55. When we do that math, we would get an answer of 18.2 grams. That is my theoretical yield. That's how many grams of potassium chloride will be produced under perfect conditions, no errors. That's how much I should get. This is from the math. This is what the math tells us. Okay? Straight stoichiometry problem just like before in part A. Now in part B, in the experiment that you actually do, 16.7 grams of potassium chloride are produced. And we want to know what is the percent yield. Okay? So our equation is percent yield equals actual yield divided by theoretical yield times 100. Well, 16.7 grams are actually produced. That is how much I actually got. So I put that number on top, 16.7. My theoretical yield comes from the math, the stoichiometry, which we did in part A. So the theoretical, what I should have gotten in the experiment, is 18.2 grams. So I put that number on the bottom. So in my calculator, I would do 16.7 divided by 18.2 times 100, and I get a value of 91.8%. So this is actually pretty good. I expected to get 18.2 according to the stoichiometry. In the lab, I got 16.7 for a yield of almost 92%. That's actually pretty good. Remember, the higher the yield, or the higher the percent yield, the better the experiment was. There were less errors. We got almost 100% of what we wanted. Okay, so use this as an example as you complete the rest of the problems. Okay, you have 2, 3, 4, and 5. So you have 4 problems, each one just like the example. You do a stoichiometry problem in part A, and then you use that value as the theoretical yield in part B, where you will calculate the percent yield.